So missing data is very common, right? And we're going to have to be able to deal with it. So the data set we're looking at today is a kind of ratings for chocolate bars. Right? This is why I ate my chocolate, or at least that's why I'm telling myself. So we'll read the data in. We've got 10 different variables. We've got about 1,700 nearly observations. And let's have a quick look using the summary. So we've got things like the company that produced the chocolate, the name of the chocolate, reviews, the cocoa percentage, the type of bean, this kind of information. Right? And you can imagine what you might do if you were trying to produce better chocolate is to look at a huge amount of this kind of data and work out what it is that customers like and what it is they don't like. Right? This is going to be quite common in market research. So the first thing we're going to do, right, we've received this data, we know now what the columns are, but we don't really know anything else other than this. So we're going to have to start looking through and seeing, first of all, is there any missing data? Right? So we're going to use the sapply function for this. The sapply function will apply a function over our data set. So for each column or each attribute of our data, we're going to apply this, and the function we're going to use, we're writing ourselves. So it's going to be the sum for any time where our item is either blank or NA. Now blank means an empty string and NA means literally not applicable, right, which is something that comes up in data from time to time. Right, so in any case, both of these are missing values, and so we're going to treat them both the same. So if we apply this to our chocolate data set, then we're going to see that, for example, there are 8 missing names, there are 7 missing review dates, and there are 4 missing cocoa percentages. So for each row in our data, there are 4 rows where the cocoa percent is missing. Right? Now that's not too bad. I mean, this is a data set of nearly 1,700 items. 4 is not too bad. Right? That's quite expected. You might imagine that if you're pooling this data from lots of different sources, people are going to forget to add data in, or they weren't able to record data on that day. There's a huge amount of reasons why you might have missing data. And now it starts to become a little bit of a problem when we look at things like bean type, because bean type has got 1,200 missing values. That's a huge proportion of the data set, and in that case, we might have to do something about this. So the only issue we've got is that 1,200 is not relative, it's just an amount of rows. It's not relative to the size of the data set. So we're going to use the exact same function, any empty rows, but this time we're going to divide by the total number of rows. So we can get a percentage for how much of the missing data we've got. So we can see, for example, that company name has 0 missing data, whereas bean type has 74% missing data. So that's a huge problem. Now, a kind of general rule of thumb is if you've got over half your data is missing, it's going to be quite hard to estimate or guess what that data is going to be. That's when you might want to start thinking about removing it. So what we want to do is we want to extract any of the names of any of our attributes that have this sort of over, let's say, 60% missing. Right? So we're going to start by calculating all those percentages and saving them in a variable, and then we're going to select only those percentages where the value is over 0.6, right, or 60%. So we're going to say any attribute where the attribute is over 0.6, and that is just bean type at 0.74, right, or 74%. So we can now delete bean type ourselves, so we could say something like choco, all the rows for bean type is null, right? And by setting that to null, that's just going to delete that column. We could also do it automatically, so we could actually pass in those attributes that we just calculated as a parameter. So that would be this line here. So it would be something like choco, all rows, that's here, the names of any attributes where the percentage missing is greater than 0.6. Right? And that's going to just delete bean type, right? There's not a lot we can do about bean type. We've only got 25%-ish of the data. It's not enough to start guessing what bean types are going to be in other chocolate bars. Let's have a look at now our rows of data, right? So for each instance, they're going to have a number of attributes. Now there's 9 left. And we want really to keep the instances that have the majority of their data. Right, so we're going to apply, right, so this is going to be row-wise, to dimension 1, so that's the rows. We're going to count any that are blank or NA for each row over our data set, and we're going to put this into missing. So what this is going to do is return a list of values for every single row that tells you how many missing items are there in that row. And so we can now look at the first few missing items. So we're going to order them, right, by largest first, and then we're going to show just the first few, and you can see that actually some of them are missing 7 and 6 attributes. That's quite a serious situation, because there is only 9, right? So they've actually only got a couple of entries in their fields. Now let's do this again as a percentage of the number of attributes. So this is exactly the same thing, but this time we're dividing by the number of columns, right, which is 9, and we're going to have a look at the top of these. And so you can see that we're missing 77% of some of these initial attributes. That's a real problem. Missing is the same length as the number of rows we've got. So we can actually look up any rows where there's a greater percentage of missing values than we want and just remove them from the data set. So what we're going to do that is a bit like this. We're going to say Choco is Choco anywhere where missing is less than 0.7 and then all the columns. And what that's going to do is select only the rows we want where they've got a nice amount of data. So the Choco dataset is going to be a little bit smaller now, but much more useful to us. We don't really want to be trying to do things like machine learning or statistics when 70% of some of the data is missing, right? That isn't going to be a good idea. So it's quite easy just to delete data, right? I mean, in some sense, it's just more convenient to do that. In general, the rule is that if you've got more than 50 or 60% missing data, it's a good idea to delete it, right? Delete either the instances or the attributes, depending on how much data you've got missing and where, right? If you're missing a huge amount of data, then you're not going to be able to recreate it by, let's say, using an average, right? We've got so little data that an average isn't going to be reliable. If we have got sufficient data that we could maybe start to infer what these missing values might be, we can start to try and replace them instead of deleting them. So what we might do is we might, for example, set them all to 0. Maybe if an attribute is missing, we can say, well, okay, if it's missing, we'll just not use it and we'll say it's 0. Right, now, whether you do that is going to depend on what the attribute is. Some things, 0 is not a useful property, right? And we'll look at that in the chocolate dataset in a moment. What we might also do is we might start to add the dataset mean into those attributes. So maybe we don't know what the rating for this chocolate bar is, but we can guess that it's going to be around the average rating for any chocolate bar. Again, this is going to depend on your situation, right? You're still making up data in some sense. You've got to be very careful about what you do here.